Why am I so pessimistic about the progress of humanity? Which kilonova did all our heavy elements come from? What's the deal with dark stars? And in our free Q&A Plus on Patreon, can a single nation realistically have a lunar outpost? Answer all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into this week's questions. Conspiracy theory enthusiast. Is there any evidence of the specific kilonova that must have gone off to create the gold, etc. on Earth? I would think that would have to have been relatively close in galactic terms because gas can only travel so far. So astronomers think that a couple of million years before the solar system formed, a kilonova went off within about 1,000 light years of us, and that it produced 0.3% of the heavier elements on Earth. 0.03? Anyway, it's about an eyelash's worth of mass of your body came from that one specific kilonova. So there would have had to have been a lot of them. There would have had to have been many kilonova that went off in our vicinity, one after the other, for billions of years, that enriched the solar nebula with material before it all turned into the solar system. Andy Bang, you didn't even mention dark stars in your first year roundup of JWST. If it sounded like the most amazing thing, can you tell me where the theory is now? So this idea of dark stars essentially is that early on in the universe, there could have been stars that were made of dark matter. And this would solve a bunch of problems in astronomy, that this stuff would collapse together. I think it's that they would turn into supermassive black holes because they don't have a cross section. This is just like a theoretical idea. There's a woman, and I forget her name. I've interviewed her once, who has been proposing this theory for a long time, that there are stars made of dark matter. And that would answer a bunch of questions, and sort of that would answer some of the observations early on in the universe. But it wasn't an observation by James Webb. It was a theory by a group of researchers based on some observations by James Webb. James Leatherwood, how would you even differentiate a fourth generation star from a third generation star? That's interesting. I don't know if you could ever get a fourth generation star. So, I mean, the star generations, right? The first generation of stars, those are the ones that were made out of the primordial hydrogen and helium left over from the Big Bang, and they collapsed down, and they were probably monster stars. I mean, they could definitely get to that, 100 plus times the mass of the sun, but we don't really know how big they could have been. But some theories say that they could have been maybe tens of thousands of times the mass of the sun. Like, they could have been really big. And then they would have lived very short lives. They would have detonated supernova. They would have released heavier materials. They would have gone through some nucleosynthesis. They would have released heavier materials that would have polluted nearby nebulae. Those nebulae would have collapsed down, and you would have gotten stars that had some heavier elements. Remember, astronomers call anything heavier than helium a metal. So oxygen, metal. Carbon, metal. Lithium, metal. And so the second generation stars, these are the metal poor stars, and astronomers see plenty of examples of those in the Milky Way and out there in the universe. And they can have like 1/1000th the metal, 1/10,000th the amount of metal that the sun has. And so they're old and very metal poor, that they formed in a time when they mostly formed out of hydrogen and helium with trace amounts of other metals delivered by those first generation stars, or maybe colliding neutron stars, things like that. And then the third generation stars, that's stars like our sun. And stars, the sun is a pretty average main sequence star in terms of its metallicity. There are stars with about 3 times the metal that the sun has. So they can be more metal rich than the sun is. So what would be a fourth generation star? Something with way more metal, I guess. But we're already reaching the end of active star formation. And so a lot of the busiest times of star formation happened billions and billions of years ago. Like cosmic noon was just a couple of billion years after the universe began. And now the universe is winding down. And so you're not going to get a lot of chances for supernova to go off, to enrich various high, nebulae with additional material, and for that to collapse down and turn into stars. So I can't imagine that there will ever be a fourth generation star. Snurz, you are way too pessimistic about human progress. I don't think so. I think I am realistic, but obviously that's what every pessimistic says, right? That they're pessimists says they're just realists. But like when I started Universe Today 26 years ago, I was reading two books. I was reading The Case for Mars by Robert Zubrin, which was all about how humanity, for about $10 billion, could send missions to Mars. And it blew my mind because I had read the Red Mars, Blue Mars, Green Mars trilogy. I was really invested. I, had been fascinated. I loved science fiction as a kid. I remember the Voyager missions. I had books about space. And the topics that I was most interested in was human space exploration. I wanted us to have a city on Mars. I was also reading Pale Blue Dot by Carl Sagan. And it was those two books that I was reading got me so inspired about the future of humanity in space that I started a website, that I changed my career to become a space journalist. And then I went on to report on the reality of what's happening in space and astronomy. I've interviewed Robert Zubrin 5 times, I think. We've talked many times, as well as, I've had a chance to interview many of the people associated with human space exploration and sort of the future of humanity in space. I've interviewed people who are working on interstellar spacecraft. I've interviewed people who are working on light sails and solar sails and the solar gravitational lens, and people who are figuring out practical ways to sort out landing on Mars. I've probably interviewed 20 people about different ways that you can extract resources from the moon and Mars, about exploring lava tubes, about how you could fly through the plumes at Enceladus to understand them better. So what you call, forget the word that you used, but that I am a buzzkill about space. This is me sort of projecting 26 years of experience about watching this unfold. I've probably looked at 40,000 stories. We have about 35,000 articles on Universe Today, and I've found most of them, right? The way the website works is that I read through the journals, and I read through all of the papers, and I read through all of the abstracts that people are giving at conferences, and I look through all the press releases from NASA and all that, and then I find all these stories and I feed them off to the writers, and the writers write stories about them, and I'm sort of thinking and I'm building this mental map of how progress is going in space exploration across dozens of different fields at different rates. Where are we at in rocketry? Where are we at in situ resource utilization? Where are we at in spacesuit development, in vehicles that can drive on Mars, in landing systems that can get us down onto the surface of Mars? And where are we at in funding for this kind of stuff? And so, is the science fiction future possible? Yes, if the funding is there. The funding is not there, right? That you're seeing a decline in the funding, the amount of money that's being spent on space exploration. You're seeing a reduction in the amount of money that's being spent on planetary science and various kinds of science. And so that, when you go back and look at the Apollo era and you look at how they put humans on the moon, and they did it for $350 billion of inflation-adjusted money. The entire, early NASA age was $500 billion. Right now, NASA gets $20 billion a year. So it's like a fraction of what they used to get. And so, yes, there is SpaceX. And SpaceX is a profitable company, and they're launching Starlinks. But I don't know what the total revenue from SpaceX is, but it is not $50 billion a year that they can just spend on sending people to Mars. So I think that we have, all of us who love space, that we come into this with a head filled with science fiction and expectation and enthusiasm for the subject. And you will become me in the future. 25 years from now, you will go, I remember that time when I called Fraser a buzzkill. And here I am 25 years later, and I have all these amazing wonders of science around me, and yet we still don't have a human city on Mars, right? But then the other thing that I always try to say is that it's all about time frame, that our technology advances, and that the things that were impossible before become routine and easy and everyday. And that if we could unlock a fusion drive, if we could unlock a dense form of energy like antimatter or metallic hydrogen, then that would change everything. That if our technology to be able to harvest resources and live off the land on the moon or Mars gets better, then that allows more stuff. And you can kind of just look at the overall growing gross domestic product of humanity, and you can just plot that forward into the future and say, oh, we're not going to live on Mars in our lifetime, but it is inevitable that humanity will be living across the entire solar system within 200 years. And so it's not that I disagree with the outcome. It's just that I am less optimistic about the timing than you are. And that's fine, right? I'm not here to tell you what you want to hear. I'm just here to give you my experience. I'm just here to report, to be a journalist, to tell you, I am synthesizing tens of thousands of stories about progress in space exploration and thousands of conversations that I've had with experts in space exploration. And that is turned into an opinion or an observation that I've made about how this future will unfold. And so I think it's perfectly fine for us to disagree. And you can probably go and find YouTubers who will tell you what you want to hear, right? They're going to tell you you're going to have a city on Mars. They can tell you you're going to keep all our eggs in multiple baskets and that the starships will be flying any day now. But my guess is 25 years from now, you'll look back and go, wow, how come it didn't happen? Or, how come we unleashed a robot apocalypse and now we've all been turned into computronium and they're dismantling all of the planets in the solar system. And the concept of a city on Mars just doesn't make any sense anymore because of AI doom. But, that's another path that the future could take. It's time to shout out all the new $5 patrons: Tom Hill, Sharon Polkowitz, Alan Main, Ian Spence, Jim LeBlanc, Matthew Schold, Kaylee Talk, Keith, Michael Pales, and Robin Lundell. Join the club at patreon.com/universe today. Brian B. Hawking radiation is accepted as fact, but is basically unmeasurable since the values are so minuscule. Does this put it in the category as string theory, an untestable mathematical proposition? No, I wouldn't put it in the same category as string theory because it's built on more of a foundation of the observations that have been made about black holes and the other observations like Hawking radiation is this sort of merger between this understanding that there is fields in all of space-time and that when you accelerate through fields in space-time, you will experience radiation. And the equivalence principle that being in the gravitational well of a black hole is the same as accelerating. And so if you experience radiation while you're accelerating through space, you should experience radiation coming from the gravity well of a black hole. And so those are, right now, no Hawking radiation has been observed, but it is theoretically possible to observe Hawking radiation, and people, can imagine experiments where they may be able to do it. So no, I think that with string theory, and look, I don't know a lot about string theory, but my understanding is that people have been trying to take gravity and quantum mechanics and, now KISS, and they don't. And so someone figured out that if I look at this, if I consider it within 11 dimensions, then suddenly the math is able to work. And that's really exciting. That's really interesting that someone was able to take these two theories that are like oil and water and actually make them describe each other in a way that's mathematically correct. So, who wouldn't be excited by that? Now, obviously, if you've figured out this way to make these two concepts that people have been trying to unite for a century into one thing, and you've got a mathematics that predicts how this should behave, then you're going to try to figure out a way that you can observe it. And the problem is that it's so difficult to observe, but not impossible. And so I do think that, people will eventually come up with some clever way to test whether string theory is correct or not. In the same way, they'll come up with a clever way to test whether or not Hawking radiation is correct or not. So I wouldn't count out any of these theories. I think the challenge, the thing that, the Sabine Hossenfelders and so on will rail against is the amount of money that's spent, the sort of the dogmatic perseverance by various mathematical departments to continue going after this theory. But I think that it is an individual choice by every scientist, every theorist who looks at the vast landscape of ideas that are on the cutting edge, and they think, well, where do I want to invest my time, right? What seems like I can make the most progress? And string theory is one that appears to be one that people can make progress. And in fact, string theory has provided benefits, mathematical benefit. It hasn't solved the underlying nature of reality, but it has provided, mathematical tools that have allowed other practical things. So, there are always these side benefits. Are those side benefits worth the amount of human capital? You just don't know. This is what discovery and exploration looks like, is we don't know what's going to work and what's not going to work. If we did, then it's called engineering, right? But since we don't, it's exploration, it's science. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus, and this week's bonus question, could there be a single nation lunar outpost? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everybody who asked your questions in the YouTube comments, but everybody who showed up for the live show. Now, we do this 2-hour live stream every Monday at 5 p.m. somewhere in the world. The time rotates depending on which hemisphere we're attempting to serve. So check out, there should be a link to the upcoming episode here on the channel. Now, I'm going to give you some updates on my C-Star, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Belock, Cy Nelson, David Gilton, and David Matz, Dustin Keeble, Evan Pro, Greg Feely, Heinz Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Mozzo, Paul Robach, Rain Kaidu, Robeck, Sean Sargent, Stephen Fowler-Melly, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got a couple of nights of clear skies, and so I was able to finally get the C-Star S50 rolling outside my front door, and I've learned a ton about it already, just stumbling forward, learning how to use this telescope. I've got it here, and this time I've actually got the lens going. So it's an amazing little telescope, and the quality of the images are quite good. Although, I haven't put in the time, so I'm going to share just a couple of rudimentary images that I've taken. One of the Beehive cluster, one of the Leo triplet, which is one of my favorite galactic configurations. And there's so many satellites passing through, and so clearly, if you want to do a good job of this, you're going to have to, I'm going to have to get into various image processing software and so on. I've learned that, although you can connect to the Seastar as a Wi-Fi hotspot, you really want to put it into station mode, which will then allow it to access your local network, and then you can control it without it tying up your phone's Wi-Fi, which is a total pain. So, it's definitely got some issues with the UI, and I know that they are making things better, but still, it's kind of amazing. And you can get the smaller version, the S30. The Pro version is coming soon. And again, they're not sponsoring me. I'm not making any money from this, but I just wanted to sort of keep you all in touch with my journey in doing astrophotography locally. All right, we will see you next time.